Alright guys and girls, so you should have attempted the questions. Now if you're completely stuck, of course you can use this to kind of start you off, and then after that just have a go at the questions and you're green penning with these questions in mind. Okay, so if we look at the question number 1, now you're going to read it yourself, I'm not going to read them out, I'm just going to simply go through the answers. Okay, so I'm using Andrea's method, EMC, and I've written delta theta here just so that you get used to seeing that. Delta theta basically means change in temperature. So what I'm going to do, I'm going to look at the question and fill it in. So firstly it says calculate the energy, so that's going to be my question mark. Okay guys, so I'm looking at the question and I've done Andrea's method, EMC, delta theta, just so that you guys get used to seeing that as well. That just means change in temperature. So looking at the question, they've asked me to calculate the energy, so that's the question mark. My mass is 1.3 kilograms. A specific heat capacity is 380 joules per kilogram degrees Celsius. And delta theta, well, delta means change in, so they've given me 25 to begin with, then it rises to 45, so the change there is 17. Right, so it's equals MC delta T. All my units are fine, so I'm just going to enter in the number and that will give me my end answer. And of course the unit is, so it's 8398 joules. Now a couple of things, units were fine, so I could just do the question straight away. So, and the other thing is, right, I don't agree with this just being 1 mark. Okay, I think the marking for this is rubbish. Okay, it's probably worth a lot more than that, and that's the same throughout with all these questions. Read the question, I'm not reading it, I'm just going to go through how to answer it. Alright, so in this question they tell you that the energy is 8,398 because it's the same as the previous question. The mass they tell you is the same as the previous question as well, so that's 1.3 kilogram, and the specific heat capacity is 4,200 joules per kilogram degrees Celsius. And what they're asking you to work out is the change in temperature. Now they're telling you that the initial temperature is 20 degrees Celsius, but we want to work out the overall temperature change and then add it on to the initial temperature, and that will give you the overall change. So using the triangle, that would give me a delta T, or delta theta in this case, is equal to E divided by M times C. So the answer for delta theta to 3 significant figures is 1.54 degrees Celsius. Now let's read the question. The question says, what would the final temperature be? So what we need to do is the final temperature would be 20 degrees, because that's what we started with, and then we're going to add 1.54 because that was the overall temperature change, so that's going to give us 21.54 degrees Celsius. That was the overall change. Have a read of this question. Now the way I would answer this question, because it's a comparison question, it's saying how much more energy would you save by doing one versus the other. What I would do straight away is split the page down the middle. Okay, that's straight away what I would do, and that's going to help separate my answer on both sides. Okay, so what we're going to do is we're going to do for both sides, okay, the same thing. So here I've used Andrea's method, EMC delta T, and we've got 2 situations here. One where, well, in both situations it's starting at 16 degrees Celsius, but in situation number 1, which I've done here, I've said that it's finishing at 50 degrees. In situation number 2, the change in temperature is going to be different because it's going to start at 16 but it's going to stop at 30. That will allow us to work out the energy for this scenario and scenario B, and then we can subtract the energies and that will give us our end answer. So of course in both of these questions the equation that we're using is E equals MC delta T, because that is, or delta theta, because that is what is missing. Right, so now that we have both energies, what we can do is just work out the difference, and that is how much energy we will have saved. Once we've worked out both energies, we can just subtract quite simply, and that will give us the energy saved. So the energy saved here will be, So the total energy saved here is going to be 840,000 joules. Okay guys, so with this one, nothing new. We're using Andrea's method. We're going to see what we have and find out what we need to work out. One of the beautiful things about this method is you can see if you need to change your units. So we've got 62.8 kilojoules, but we need that to be in joules. So I'm just simply going to times that by 1,000, and that will give me my answer in joules. Right, 5,000 grams, we're not happy with that, we need that in kilograms, so we're going to divide that by 1,000. And then of course we've done our temperature change because our initial was 18, 46 was the final, so we subtract it to get 28 degrees Celsius. Now we use our, so once we're happy, kilograms, once we're happy with that, what we do is we then use our triangle to work out the equation. So C is missing, so C is equal to E divided by M times change in temperature. So C is going to equal 62,800 joules divided by 5 multiplied by 28. Of course I've left some units out, but you guys shouldn't do that. And so this will be my specific heat capacity value. So it's 448.57 joules per kilogram. The answer to this question is because if you have watched the tutorial on how to carry out the specific heat specific heat capacity experiment, you'll notice that we need to add a insulator around it. If you don't, then the thermal energy will dissipate into the surroundings, and because of that you're going to have heat loss, which means that you need more energy, which means that the specific heat capacity value is going to be higher than it should be, which is why when we're carrying out this experiment we need insulating material to get a better result. Okay, and the rest of the principles is the same. I'm going to stop there. Remember, megajoule means a million, so you can either do 0.03, multiply that by a million, or as I taught you last time, it's a lot easier way. You can put it in your calculator 0.03 times 10 to the power 6, and then you don't have to worry about that. And then all you have to write, so let's say energy, for example, is 0.03 times 10 to the power 6, and then that will automatically convert it into joules for you. And then when you're playing with the calculator, there's less playing around to do. But hopefully with those examples you've gotten the gist of it. Now with this one here, even though it's negatives, you can treat them as positive numbers. Okay, so you can treat them as positive because your end answer is going to be positive anyway. Okay, so hopefully that's helped, and that's the best I can do in this situation, guys and girls. Best of luck. Let me know how you get on in Teams, and then what I'll do later is I'll upload the mark scheme and you can green pen the rest yourself.